Hey there. Okay, part 2 of elimination. Part 2 of elimination. Things are going to get interesting today. If you have not watched part 1 of elimination, holy cow, go back, watch it, or else today's going to be a little crazy. Okay. We are still following these same steps, or I might refer back to them. Okay. We're just going to have a little bit more challenging problems today. So let's go. Here we go. Number 1. We have x equals 3y plus 11. Second equation, 3y minus 2x equals negative 16. Okay, so double check you wrote that down correctly. And then I am going to refer back to step 1, line up the equations. So if you notice, your x's and y's are not all lined up correctly. The equal sign is not on top of the equal sign. So we got to rearrange some things here. So I'm going to always suggest that you put your equations in standard form. That's the easiest way to do elimination. It's going to cause the less problems later on. So standard form, x's and y's are both on the left. You have your equal sign, and then you have your constants on the right. So this one is almost in standard form with our x's and y's. So we could twist those around if we wanted to. So what I mean by that, and you don't have to do this, you can put your y's first, it's fine. But for me, I always like to have my x's out front, then my y term equals whatever. So all I did for that one is I just moved the x and y around, okay? This one, we actually have to move across an equal sign. So if I want this 3y to suddenly be over here, mathematically how I would move it is I would have to subtract 3y on both sides. A lot of you know by now that if you want to switch a term from the left side to the right side, you can. All you do is you got to change its sign. If it used to be negative, now it's positive. If it used to be positive, now it's negative. So 3y on the right would become negative 3y on the left. So leave the x alone. Now you have a negative 3y, and then your 11 is still hanging out on the right. Hopefully that made sense. Okay. All we did is basically subtract 3y, subtract 3y. So you have x minus 3y equals 11. Okay, so we had to rearrange that one. And then I chose to also rearrange that one so that my x's and my y's, my equal sign, and my other numbers are all lined up. Okay, so that's step 1. Next, we're adding the two equations and we're seeing if some variables cancel out immediately. If they don't cancel out immediately, I have to force them to cancel out. So do you see any variable terms that cancel out? I do. My y's are going to cancel out because negative 3y plus 3y is 0y, aka 0, aka nothing. They cancel out to nothing. So I go like this and I put a slash through it. Okay, and that's what I want you doing. The rest of this stuff, we're just adding it up. X plus negative 2x. It's the same thing as just 1x minus 2x. You're going to get a negative x, okay? If you want to write it as negative 1x, totally fine. 1 minus 2, negative 1. Drop down my equal sign, 11 plus negative 16. Same thing as 11 minus 16, which is negative 5, okay? We want x isolated. We want to solve for x. So we divide by whatever's attached to it. Negative divided by negative, positive. X equals 5. Cool. Now we take that answer. What do we do? What do we do? What do we do? Take that answer and we plug it in for x into either equation, but it's got to be the original equations. And that's so that if we made a mistake here, it's not going to mess us up a second time, okay? But right here, we plug in a 5 for x. I'm going to suggest this first one just because x is already by itself over there. So instead of x equals, I'm going to have 5 equals 3y plus 11. Okay. Y is already on the right, so I'm going to move this 11 to the left. 5 minus 11, negative 6. So I have negative 6 equals 3y. To get y by itself, divide by 3. Get negative 2 equals y. So y equals negative 2. Okay. Last thing we do is we just write our final solution as an ordered pair. Our x was 5. Our y was negative 2. Final answer, 5, negative 2. Okay. Second one. Second one, here we go. 8x plus 4y equals 12. 8x plus 4y equals 12. Second equation, negative 2x plus 2y equals 18. Okay. So that's our system. I can see that everything's lined up nicely. X's, Y's, equal sign, other stuff. Cool. Now I want to see if anything immediately cancels. My X terms, I have an 8 and a negative 2. That does not cancel to 0. 4 and a 2 does not cancel to 0. So I'm going to have to force something to cancel. You can choose to cancel out your Y's, or you can choose to cancel out your X's. It doesn't matter. You're going to get the same solution. So if I wanted to cancel out my X terms, I could times this bottom one by what? I have a positive 8x. I would want to make this a negative 8x. How would I do that? I would times it by 4. So that's one option. If I wanted my y's to cancel out, I have a positive 4, which means I want to make that a negative 4y. So to do that, I would times everything in the bottom row by negative 2. So it doesn't matter. You both are going to work out to be the same, okay? But I do know that the smartest move is to times this bottom row by something. So if we were in class right now, I'd call on one of you and say, what do you want to cancel out? Because it really doesn't matter. So let's cancel out the x's. Sure, why not? Let's cancel out the x's. So we would times everything by 4. Leave the top equation the same. 8x plus 4y equals 12. The second equation, every single thing on both sides has to be times by positive 4. So 4 times 2, negative 2x is negative 8x. 4 times 2y, positive 8y. 4 times 18, 18 plus 18 is 36. 36 times 2 is 72. I want to check my math though because I'm scared. 18 times 4, 72. Yes, 72. Okay, so we times everything in the bottom by 4. Now we can see that these x's cancel. That was the whole point of that. And we add up the rest. 4y plus 8y is 12y. 12 plus 72 is 84. To get y by itself, I divide everything, or divide both sides by 12. 84 divided by 12 is 7. I'm just making sure. It's been a long day. Yes, it's 7. Y equals 7. Okay. Now what? I know what y is. Now we have to solve for x. How do we do it? What do we do with this 7? Plug it in somewhere. You can plug it into the top or bottom. Does not matter. I'm going to choose to plug it in the bottom because I have lower numbers to multiply by. So negative 2x plus 2 times 7 equals 18. Okay, so 2 times 7 is 14. Drop down the other stuff. All my x's are to the left, so I want to get rid of the 14. 18 minus 14 is 4. Divide both sides by -2. Yeah, x equals -2. Final answer, final solution, -2, 7. Boom, 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 boom. Okay, I'm hoping this makes sense. You gotta see what eliminates. Sometimes you have to force things to eliminate. Here's number 3. Number 3, okay, 3x minus 5y equals -12. Second equation, y equals -x minus 4. Okay. Are we all lined up nice and pretty? No. Okay, this first one is in standard form. We like that. This other one's in slope intercept, which is cool sometimes, but in this case, I think it's a great thing to do is put them in standard form. So what that means is we would want to move this x, this -x, to the other side. So if I were to move over a -x on the right, if I were to move it to the left, it would become +x. And that's because you are technically adding x to both sides. Okay, so if I move that over, it becomes +x, hanging out with a +y, and over on the right is still that -4. So all I did was moved my x to the left by adding x to both sides. The top equation we didn't touch, so just copy it over. Okay, so now we're all lined up. Now let's check to see if anything cancels out. Do your x's cancel? No. Do your y's cancel? No. So we have to force them. I noticed that it would be easier to times this bottom row to cancel out the x's, and it would be easier to times this bottom row to cancel out the y's. So we are going to be timesing this bottom row by something, and it's completely your choice. Do you want to cancel out the x's or do you want to cancel out the y's? Doesn't matter. Since it's just me here, I'm going to say let's cancel out the x's because it's a lower number. What would we multiply everything by to cancel out your x's? I have a +3x, so I want to make this a -3x. So I would times everything by -3 in that bottom row. So I'm going to rewrite this over here, okay? The 3x minus 5y equals -12. Literally, we're not doing anything to it. Everything in this bottom row needs to be times by -3. -3 times x is -3x. -3 times y is -3y. -3 times -4, +12. Okay, we rearranged. We had to multiply so that things eliminate. Holy cow. But finally, your x's eliminate. Woo. Now let's see what happens with our y's. -5y plus -3y is -8y. -12 plus 12 is, some of you are like, they cancel. Yeah, they do, but we can't leave nothing on that side. We have to show that they cancel to 0. You have to put a 0 over there. Is this going to be no solution? Let's see. To get y by itself, we divide by -8. 0 and division. Sometimes it's ugly and sometimes it's fine. If 0's on top, it's okay. That means it results in 0. 0 divided by anything is 0. If 0 were to be on the bottom, that's where we would run into illegal math. Okay? 0 divided by -8 though is 0. So y equals 0. Okay? So we're going to take that answer of 0 and plug it in and solve for x. It doesn't matter which one I plug it into. I would actually suggest, it doesn't matter. We can plug it into this top one. So we have 3x minus 5 times 0 equals negative 12. Okay. Negative 5 times 0 is just 0. So you have 3x plus 0 equals negative 12. 3x plus 0 is just 3x. Okay, so basically that just canceled out. So if 3x equals negative 12, divide by 3 on both sides, and I get x equals negative 4. So my final solution, I'm going to squeeze it in right here. Final solution is negative 4, comma 0. Final answer. Okay, hoping you're getting the hang of this. Here's number 4. We're kicking it up a notch. Here's number 4. 3x plus 3y equals 9. Second equation, 5x plus 4y equals 10. Okay, so check that out. Alrighty. Are we lined up? Yes. Can things cancel out immediately? 3 and 5, 3 and 4? No. We have to force one of them to cancel out. So if you wanted to cancel out your x's, you have a 3 and a 5. You can't times one of these to suddenly, like I can't times anything by 3 to become negative 5, because 3 is not a factor of 5. Okay. Same thing with 5. I can't multiply 5 by any nice number to make it suddenly negative 30. Okay. So you're actually going to have to times both of these in order for them to cancel out. You would want to make one of them positive 15x and the other negative 15x. Let's check to see if the y's are easier. 3 and 4. This is one where you would have to also times both equations, and you would want to make them either into 12y and like negative 12y. You could go higher up to like 24 and negative 24, but smaller the better. So when one of the numbers is not a factor of the other, we have to times both equations. So we can still choose whether we want to cancel out the x's or y's. We've been canceling out x's lately. Let's do y's this time. And I'm going to have to multiply both equations though. Okay, so 3 and 4, the least common multiple is 12. So we would want to make 12y and negative 12y. Let's do the top one as positive 12. If I want to make this a positive 12, I would times it by a positive 4. So let's go ahead and do that. 3x times 4 is 12x. 3y times 4 is 12y. 9 times 4 is 36. Okay. Now, let's figure out what we need to times the bottom by. I'm trying to cancel out the y's. I have a 12y, which means I need to make this a negative 12y to cancel it out. So I got to times everything by negative 3. Times by negative 3. So everything in this row gets times by negative 3. 5x times negative 3 is negative 15x. Negative 3 times 4y is negative 12y. Negative 3 times 10 is negative 30. Okay. All right. So now I can see that my y's eliminate. 12x minus 15 is negative 3x. Drop down my equal sign. 36 minus 30 is 6. To get x by itself, I just divide by negative 3. 6 divided by negative 3 is negative 2. So I get x equals negative 2. I would suggest pausing right here and seeing if you can finish it up on your own. Plug in that for x, see what you get for y. Okay, so we can plug this into either equation, does not matter. I'm just going to plug it into the top, but we always want to plug it into one of the originals, not one of these. Okay, just as a way to double check ourselves. So 3 times negative 2 plus 3 times y equals 9. 3 times negative 2 is negative 6. I want to move that negative 6 over, so I'm going to add 6 to both sides. 9 plus 6 is 15. Divide by 3, divide by 3. Y equals 5. So my final answer here is -2, 5. Okay. Okay, this last one is going to be the one that you do on your own. I will help you with part of it, and then you have to finish it. So here you go. 5x plus 9y equals -10. Second equation is 7x plus 10y equals -1. Okay. Things I like about this, it's already lined up for us. We don't have to rearrange. Cool. Things I don't like is nothing cancels immediately. Okay. 5 and 7, 9 and 10. 5 and 7, one is not a factor of the other. 9 and 10, one does not go into the other. So this is a situation where we are going to have to times both equations by something. Now you just need to pick which one do you want to eliminate. You could cancel out the x's, you can cancel out the y's, it does not matter. Just for our purposes, let's all do the same thing. Let's say we're canceling out the y's. 9 and 10, I have to times them each by something so that they cancel out. 9 and 10 make 90. That's their, I think, their least common factor. Yeah, 90. So I would have to make positive 90 and negative 90. So let's go ahead and do that. If I want positive 90 on the top, I would times by positive 10. Everything by positive 10. If I want negative 90y on the bottom, I would times by -9. Okay, so I'll help you get that, and then the rest is going to be yours. So if we times everything in the top row by 10, we would get 50x plus 90y equals -100. Times everything in the bottom row by -9, you would get -63x minus 90y equals +9. So when you add that up, your y's are going to cancel out, and you need to keep solving. Okay, you need to find the final answer as a solution, parentheses x comma y. Okay, I know it's a lot, but you got this. Promise. See you in class.